For today's video, I will be starting off by explaining logarithms and how to isolate and solve for the variable. So first, before I get started, I will be explaining the difference between exponential form and logarithm form. So this right here would be exponential form. It is when a is raised to the power of c equals b. Whenever you see anything in exponential form and you would like to change it into logarithm form, you would change it into log base a of b equals c. However, in some calculators, they do not have the log base equation, and in that case, you could just put log b over log a, and it would still get you c. Now, moving on to the laws of logarithm, this right here, log base n times ab is the same as log base n a plus log base n of b. Second, we have log base n a over b is the same as log base n a minus log base n b. Lastly, we have log base n a raised to the power of r is the same as r log base n of a. So everything that I have explained for the laws of logarithm, everything on the right would be the long expanded form, and when you have to condense or make it shorter, these are the short and condensed form of the long and expanded form. Now I will be going over our first example. So for our first example, I have x raised to the power of x equals log base 3 of 7 minus log base 3 of 2. So first, as you remember from the previous slide, I went over the laws of logarithm, and as you can see right here, this is expanded form, and you can shorten it into the condensed form. And that form would be log base n a over b. And so once you have shortened the expanded form, you would get 5 raised to the power of x equals log base 3 of 7 over 2. So then next you can see this is in exponential form, and because it is in exponential form, you would have to convert it into logarithm form. And if you remember, in order to change from exponential to logarithm, it would have to be log base 5 of log base 3, 7 over 2 equals x. And like I've stated before, if your calculator does not have the log base button, you can simply put in log 7 over 2 all over log 3, and you would get log base 5 of 1.14 equals x. And like in this case before, if your button does not have the log base button, you can simply put this as log of 1.14 all over log of 5, and you will get the answer as x equals 0.082. For our next example, we have the problem of 2 raised to the power of negative 5x equals 52. So if you can see right away, this form right here would be an exponential form, and you would have to convert it into logarithm form. And once you have converted it into logarithm form, it would be log base 2 of 52 equals negative 5x. Now you would be solving for the answer of log base 2 of 52, and like I've said many times before, if the calculator does not have the log base button, you can simply put log 52 all over log 2 equals negative 5x. And once you input that into your calculator, you would get 5.7 equals negative 5x. And from here, it would be basic algebra where you would have to divide negative 5 to both sides. And once you have, you would get x equals to negative 1.14.